What's going
Yeah,
on
good evening.
here?
Welcome to my channel.
Let's have it.
This is
Let's have it.
Just through the Knowledge Electrical.
Let's have it.
And today we'll be
Let's
sharing
have it.
one important topic today. Like you always know, under corporate social responsibility, it is my right to get you up to speed of latest information about electrical engineering. Today we'll be talking about star delta. Most persons do not understand what a star delta does in an industrial setting. Most times we see star delta connected to an electric motor. Now, what is actually the very essence why we introduce a star delta to an electric motor? First, once you start an electric motor directly unload to your generator or to your supply line, you notice this more like a vibration, or so to say, the electric motor draws above starting needed current that causes it can even break down your generator. For example, like this, when you plug your iron to a 950 generator, you notice that the generator struggles to maintain stability. So the same thing applies in an industrial facility, maybe your Coca-Cola company, where electric motors are very essential electrical equipment. So in such cases, those big electric motors need a star delta to step down the system, to step down the needed starting current, so that once the motor maintains a startup speed, it can switch on to delta. Now there are two types of connections that you can find out in your electric motor.
What is
It
this
can either be
saying?
star or delta connection. Now what is the very meaning of this star delta or these individual terminologies that I mentioned? Now a star is a setting. Let's say your winding, at the end of the day, you have reduced it to 6 output lines, where correspondingly represent U1, V1, W1, because these are roots, or these are alphabets we use to identify those 6 lines that comes out of your electric motor. So U1, V1, and W1. Then on the other side of the remaining three, you have U2, V2, W2, W2, yes. So in this case now, for you to achieve your star connection of the winding, whereby you want to star the 3 part of the winding and then the 3 part of the lines, and then connect your supply line to the other 3. So what do I mean by this? A situation where you have these mentioned lines. Now you have to star all the twos. What do I mean by all the twos? Your W2, your V2, and your U2 will be starred in one point, will be connected in one line, bridge the 3 together. Then the remaining U1, V1, and W1 will be your feeding line for the 3-phase. Now you notice we have 3-phase system. You can either have a single phase or 3-phase. Now when you connect your supply line, your 3 lines to that place, and you bridge the 3 twos, that is W2, V2, and U2, you have succeeded in having what we call star connection. And in this case, I will still bring you up to speed your resultant current and voltage characteristics in this aspect. Now going over to your delta connection. What do you mean by delta connection? A delta connection is more like you want to have a triangular form of connection. So in this case, your U1 is connected to W2. Now your U2 is connected to V2, and your W1 is connected to U2. So if you make sense of what I just said, you will see that you will have a triangular body where 2 lines are supplying to 1 coil. Now going over to what I said before, what is the resultant current and voltage characteristics of these connections? Now before going over to the characteristics of this voltage and current characteristics, let's then bring to speed why a star delta is very, very important. Now in star connection, the phase current is reduced to 230. Why do we say so? When you multiply the phase current, which is 400, because the phase current, the face-to-face voltage that comes to a star connection will be 400. But to have a line voltage means root 3 will multiply 400, which is the normal value for a 3-phase current, or normal reduced rate of a voltage line. So when you multiply root 3, when you have the resultant of root 3 will give you 1.73. When you multiply 1.73 by 400 volts, you have 230. So that is why you have every neutral to line in a star connection, you will have your 230 volts. So in this case, the voltage will be less, and as well the current will be less. So that is why in your motor, when we put up this star delta connection, that is using 3 contactors, where 1 contactor is the main, the next contactor will be delta, and the other contactor will be star. So at the start of the motor, the star and the main contactor will close, giving the electric motor a minimum amount of current and voltage, and as such reduce the tension of heat that will be going to the supply source, your generator, in other words, not to drag it down or bring about those vibrations that I talked about. But then when your electric motor has maintained a certain movement or a certain startup movement, it then switches over to the delta. What do we mean by switching over to the delta? It will now go to the rated voltage and current that the motor runs with, which we call FLC. That is the full locked current of the motor. By so doing, it will not drag the generator or the supply source down. So the founding fathers of industrial engineering deem it necessary that if we can achieve these windings in different settings, because I told you that these are different connections met on the terminal block of an electric motor. So they now thought it is important they find a way to bring these two connections in one setting. So invariably, you can't have a star delta connection at the same time without using a contactor to achieve that. So that is why they now used a contactor to bring about these two different connections that we do in electric motor together, so as to achieve a lesser torque starting current, and then when the motor starts up, it can now go over to the rated current and voltage rating.
Yeah?
So if you like
the
connections applied, do well to follow my page. This is Learning Engineering Online from yours truly, Kunus Electrical. Thank you for joining.